Hello guys, welcome to the fifth episode of System Design 100 and you're watching Caching. Now, in the previous episode we have discussed the use of load balancer and database application, how they can help us in performance and high availability, and how they can prevent a single point of failure. By introducing a master slave architecture, uh, we have saved a lot of performance overhead over database because we have created multiple copies of database, and all of the read requests, because read requests are more in number as compared to write requests every time, almost in all the types of systems. So the number of requests are routed to slaves, so that the overall, because we have more number of slaves, so the overall, you can say, load on the system will be lower. So because databases will be able to handle read very well because they are in higher numbers. Now, I would like you to imagine a situation, even extreme situation, in which there are a lot of queries coming from the users over a certain topic itself. For example, whenever there is any World Cup in happening in the world, around the world, let it be football or cricket, FIFA or IPL or ICC, anything. So certainly regarding that topic, people start to search a certain thing is called the scoreboard, and Google provides that scoreboard. So uh, it's like all of the country, all of a particular area will be searching for that. So the almost half or more than half of the searches are coming only for that. So in that case, even though we have made our our databases partitioned, and all of the reads are going to slave, but still all of the requests are going to web servers, and from web servers they're hitting the databases, and then bases are returning it. It's still quite slow, because every time database is getting hit with a query, it's returns some data, and then the data is returned to the user. And right, the databases are hosted on either on drives, like either HDD, yani hard disk drives, or SSD. SSDs are very fast because nowadays almost all SSDs are used, but still SSDs are drives itself, so they are very slow as compared to memory. So there is a concept called cache, or I call it's called cache or cache.
Cache.
Yeah, cache. So cache, let me write it here. Oh my god. Oh. Cache. Huh. Cache is a temporary storage in which a not very huge amount, very small amount of data can be stored for some amount of time, which is being frequently accessed. So it's a kind of a temporary storage. Temporary storage means it's not you might have heard the difference between volatile and non-volatile. So this is non-volatile storage as compared to, so memory, right? RAM is called memory. So caches are built over memory storage only, because they need to be very fast as compared to databases. So there are a lot of providers of caches. If you might have heard of the terms called Redis and Memcached or Memcached. I don't know how to pronounce this. So these two are very famous providers of in-memory caches. So you don't have to implement caches on your own end. So caches are somewhere placed between web servers and databases. So either I don't have space in between, so I'll create it here. So for example, we have a cache storage here in memory. I don't know, it has some this kind of icon, I don't know. So this is the cache. Okay, now what happens is that we have a lot of caching strategies. So for example, there we have a read through strategy, in which what happens, right, whatever requests comes will first go to cache. So for example, some user in India is searching for IPL, so a request will come to web servers. Web servers will first send this request to the cache. It will look for the IPL query. If it found something in this particular cache regarding IPN, it will simply send it back from here. So just imagine, right, how much time or how much querying will save over our databases. Especially if I talk about it, the performance will be improving because querying a cache as compared to querying a database is very fast. So because cache is in memory, you might have heard about the data hierarchy, right? The fastest storages are, so the fastest storage in computer hierarchy is a register that is inside a CPU, right? After that we have I guess memory of SRAM. I think, yeah, SRAM. Then we have memory of DRAMs. Sorry about that. That's the cleaning stuff. Yeah, we have memory DRAMs, and then we have SSDs, and then HDDs, then tapes. So this is the hierarchy. So right, memories are always faster than SSD, and they're quite fast. It's not like there is a small difference. There is a very huge difference between performance of memories and SSDs. So caches are in memory storage devices which are not very huge in size, but they are very fast. So they are made for the purpose so that they can store temporary data which is very frequently being accessed for a period of time. Okay, so uh, this we were talking about the strategy, right? The read through strategy. So there are multiple strategies. I like to tell you there are multiple caching strategies. We're just discussing the read through strategy. Okay, so for example, the cache has the IPL data in it, and it is able to serve. What, for example, it does not have the IPL. For example, we are just starting the cache and it does not contain any data. What will happen in that case? The request will be routed to cache regarding the query IPL. It will try to search the cache for the query. It will not find the query, and then the request will be routed to the database then. So the same query will be applied to database. Now definitely we'll have the answer in the database, right? Because database is the main part of the application. So database will return a single query, just a single query to the cache, and then cache will store that data temporarily, and then it will give it back to the web service. Now every other query will have after this for the value IPL will be served from the cache itself, and will save a lot of queries for the data from the databases, and will improve our application performance a lot much. So this is the basic idea of how cache works and why it is needed in place. I'll talk about a very short example. What kind of data structures or what kind of storage types are present in a cache. So, uh, in cache there are a lot of there are quite a type of data structure present. One of a very common one is called a sorted set. So, sorted set is nothing, but set is a data structure in which there cannot be duplicate elements, and sorted set is a type of data structure present in cache. So there are a lot. There is sorted set, there is hashed set, there is tree set. I guess there is something like so. These are different kind of data structures. We will not go in depth for these. What are these and how these work, because it is we're studying. The name of this course is System Design 100. So it discovers what exactly the topic is. Not we're not going into depth. Maybe some other video. So these are type of data used. So every application, whatever type of application you're using, might have a different kind of scenario or a different kind of data or different kind of data processing it is handling. So multiple type of data sets can be used in different scenarios. So yeah, these kind of data sets are present. For example, hashed set, if I talk about it, if you have used something called a hash table in programming languages, you might have heard, right? We do it generally like we store the data in a key value pair. Something like, for example, the name of our hash table is student, so we'll add like student dot set, and then the roll number against the name. So the roll number will be key because the roll number will be unique, and the name will be the value for that. And to fetch it, it would be like something called student dot get, and then the name of the roll number. Okay, so Yeah, it is something like that. So it is nothing but a data storage, and there are multiple type of data storage present in cache, so that you can implement that in your application depending upon your which scenario you are working on.